Navigating the huge landscape of web development frameworks can sometimes feel like you need, I don't know, a secret map or something, or maybe a shortcut just to figure out what makes a tool really stand out from the crowd. It's just so easy to get lost in the jargon, or buried under documentation when you just need the core ideas. But not today. Today, we're doing a deep dive into Angular. It's that comprehensive framework from Google, and it's really proven itself in some of the biggest web apps out there. So, our mission for you today is simple. We want to unpack the most important bits of knowledge, the real nuggets, straight from the latest Angular docs. We'll look at how Angular helps developers build faster, more performant, and definitely more secure applications. And we'll touch on why it's such a game changer for keeping teams productive, especially the big ones. Think of this as like your personalized guide to getting well informed about Angular fast, with maybe a few surprising facts thrown in. So, whether you're prepping for a meeting or just catching up on web dev trends, or maybe you're just really curious, we promise some aha moments. A clear path through what can feel, well, a bit overwhelming. We're really going to focus on how Angular helps you build with confidence, kind of right out of the box. Okay, let's dive in. All right, so when we talk about Angular's core, we really have to start with this idea of a fine-grained reactivity model based on signals. Now, that sounds a bit technical, I know.
But this is really where Angular simplifies things and helps build faster apps, almost by default.
Yeah.
How exactly do these signals make that happen?
Yeah, it's actually quite clever. Signals let the framework track really granularly how and where your application state is being used everywhere. And this precision, this tracking, it gives Angular the power to render updates incredibly fast. It uses these highly optimized instructions. So instead of, re-rendering big chunks of the UI or maybe even a whole component,
Sure.
Angular only touches the exact parts that absolutely have to change. It's like surgical precision for UI updates.
Wow, okay, surgical precision.
Yeah.
That sounds incredibly efficient for performance. So what are the main types of signals you work with, the sort of building blocks?
Well, you primarily deal with two types. First, there are writable signals. They're pretty much what they sound like. You create them with the signal function, and they give you a direct API like set or update to change their values.
Yeah.
Simple enough.
Then you have computed signals. These are defined using computed. And these signals get their values by deriving them from other signals.
Okay.
Now, the really powerful part here, and this is key, is how they're lazily evaluated and memoized.
Lazily evaluated and memoized.
Yeah.
What does that mean in practice?
It means they only calculate their value the very first time you read them. Then they cache it. They only recalculate if, and only if, one of the signals they depend on actually changes.
Yeah.
This isn't just a small optimization. It's like a fundamental shift. It lets you write complex data transformations, even computationally heavy logic, without constantly worrying about performance bottlenecks. It basically shifts that optimization burden from you, the developer, onto the framework itself.
That is a huge benefit, taking that performance headache away. And signals also power something called effects, right? How do they fit into this whole reactive picture?
Right, effects. Effects are basically operations that run whenever one or more signal values change, and they always run at least once to start. Similar to computed signals, effects dynamically track their dependencies, so they only pay attention to the signals that were read during their last run.
Okay.
And that dynamic tracking is really important because it ensures the effect only reruns when it absolutely needs to.
So what would you use effects for? What are the typical use cases?
Oh, lots of things. Think about anything that's not directly updating the UI and the template, like logging data for analytics, maybe syncing your app state with local storage,
Right.
or handling custom DOM behavior that's tricky to do in templates, even integrating with things like charting libraries or other third-party UI stuff.
Got it. So this fine-grained reactivity, it sounds great in theory, but how does it directly help a developer improve performance, especially with something like on-push change detection?
Yeah, that's where the magic really connects for on-push components. So on-push is a common strategy in Angular, a really effective one for optimizing performance. Components usually only re-render if their inputs change or an event happens inside them.
Okay.
But when you read a signal inside an on-push component's template, Angular automatically tracks that signal as a dependency for that component. Then when that signal's value changes, Angular automatically marks that specific component to be checked and re-rendered. It bypasses the usual on-push limitations.
So the component just updates automatically when the signal changes, even with on-push.
Exactly. It means on-push components just work with signals, automatically re-rendering when needed, skipping unnecessary checks. It's a massive win for performance. It really helps make performance the default, not something you have to constantly fight for.
Performance by default. I like the sound of that. And speaking of that, Angular also helps meet performance targets out of the box with things like server-side rendering, SSR, static site generation, SSG, and hydration. What's the bigger picture there? How do those fit in?
Well, yeah, they're not just buzzwords. If you step back a bit, these features directly lead to faster load times for your users. That's the big one. They also significantly improve core web vitals. Those metrics Google cares about for user experience.
Like LCP, CLS.
Exactly. FID, first input delay, LCP, largest contentful paint, CLS, cumulative layout shift. Better scores there mean a better user experience, and ultimately that usually translates to better SEO for your application too.
Okay, and hydration is a key part of that, especially with SSR, isn't it? What's actually happening when an Angular app hydrates?
Yeah, that's a great question. Hydration is where a lot of that initial perceived performance comes from. Essentially, it's the process where your server-rendered application kind of wakes up on the client side. So Angular gets all that HTML the server sent down. And instead of just throwing it all away and rebuilding the DOM from scratch, which is what causes that annoying flicker you sometimes see.
Yeah, I hate that flicker.
Right. Instead, Angular intelligently reuses those existing DOM structures the server already built. It's kind of like getting a prefabricated house delivered and just connecting the plumbing and electricity rather than tearing it down and building it again brick by brick.
Nice analogy.
It persists the application state, transfers data the server might have fetched. The real win is it avoids recreating DOM nodes. No flicker.
So it's about efficiency, smoothness. How do you actually turn this on? Is it complex? And what if, say, one specific component messes things up?
Good questions. For SSR apps, you can usually enable it really easily right through the Angular CLI. It's often just a command flag. Or you can do it manually by adding provide client hydration to your app's bootstrapping providers.
Oh, okay.
Now, sometimes you might have an older component or one doing direct DOM manipulation, maybe interacting with a third-party library that touches the DOM. That can sometimes cause issues with hydration's assumptions. For those specific edge cases, Angular gives you an escape hatch. The Inkscape hydration attribute. You just add it to the components tag in the template, and Angular will just skip hydrating that specific component and its children. It's a useful workaround when needed.
Okay, a little escape hatch. Good to know. And then there's something even fancier called incremental hydration. How does that build on this?
Incremental hydration.
Yeah.
Yeah, that takes the idea of full hydration and gives you even more fine-grained control. It works with Angular's at defer blocks. You can use triggers like hydrate on or hydrate when inside those blocks. This lets you precisely control when specific parts of your application actually hydrate after the initial load.
Interesting. So you could prioritize certain sections.
Exactly. It means even content that's above the fold, the stuff the user sees immediately, can render without layout shifts, even if it's in a deferred block that hydrates later. It really opens up possibilities for fine-tuning performance, especially on complex pages. It does raise a question, though.
Yeah.
How granular can you really get with this control in a real-world app? And the answer seems to be, well, surprisingly granular. It gives you a lot of power.
Okay, so with that strong foundation in reactivity and performance covered, let's unpack the actual building blocks, the things you use to build your UI. Angular components. These really are the fundamental pieces of any Angular UI, right?
Absolutely. They're the core. Each one is basically defined by a TypeScript class paired with a @component decorator. And that decorator holds all the essential metadata, things like the selector. That's the custom HTML tag for your component.
Like app user profile or something.
Exactly. Then you have the template or template URL for its HTML structure and styles or style URL for its CSS.
And what about those styles? You hear horror stories about CSS conflicts in big apps. Do component styles leak out and cause problems in Angular?
Not by default, no. Angular uses a mechanism called viewEncapsulation.emulated. You can kind of imagine each component having its own invisible style bubble around it.
Yeah.
So styles you write for one component won't accidentally mess up the styles of another component or the global styles. Angular actually achieves this by adding unique attributes to the component's HTML elements behind the scenes.
Ah, clever.
Yeah. And you also get special pseudo-classes like .host if you need to style the component's host element itself, or .deep for, well, deeper, more global styling, though you generally want to be careful with that one.
Right, so components are these nice encapsulated blocks. How do they actually talk to each other, pass data around? You mentioned inputs and outputs earlier.
Yes, inputs and outputs are the primary way they communicate. Inputs are for passing data into a component from its parent. You declare them using the input function now, which is the modern signal-based way, like value input 0 sets up an input named value with a default of 0.
Okay, input.
You can even make an input mandatory using input.required.
Sure.
This tells Angular that the parent must provide a value for this input.
Oh, that's useful.
Yeah. And they can also have transform functions. Super handy if you need to, say, automatically convert an incoming string input to a number or Boolean right when it's set.
Nice. And outputs. That's for sending info back out.
Precisely. Outputs are used to emit custom events from a component, usually to its parent. You declare them using the output function, maybe something like panel closed output to void if you just want to signal something happened, or value changes output string if you want to send data with the event.
Okay.
You then trigger these events by calling the emit method on the output property. So this janot.panelClosed.emit. One important detail here. Angular custom events, unlike native browser DOM events, do not bubble up the DOM tree automatically.
Okay, so the parent needs to listen directly.
Yes, exactly. It gives you more explicit control over event handling.
Yeah.
And a quick best practice tip. Name your event handlers for what they do semantically, like save or items selected, rather than just naming them after the user action, like on-click save. It makes the code clearer.
Good tip. Okay, so we have components. They can talk. Now we need to actually show stuff and handle user interaction in the UI. That's where templates come in.
Yep, templates are where the UI comes alive. They use standard HTML, but enhanced with Angular's magic. You've got familiar concepts like two-way binding, usually using eng model, which seamlessly links an input field to a component property and updates both ways.
Right.
Then conditional rendering with the new add-if block or the older ngIf directive to show or hide parts of the UI based on conditions. Then loops, again with the new @for block or n4, for rendering lists of items efficiently.
You mentioned efficiency. Is there something special about how Angular handles lists?
Yes, especially with @for and n4, there's a feature called track by. This is fascinating, actually. It lets you give Angular a hint about how to identify unique items in your list, usually using an ID.
Okay, so why is that important?
Because without trackbaba, if the list data changes, Angular might have to tear down and rebuild large parts of the DOM for that list. But with trackby, Angular can figure out exactly which items were added, removed, or just moved. It then only makes the minimal necessary changes to the DOM.
So it avoids unnecessary work.
Exactly. It prevents unnecessary DOM manipulation, which can be a huge performance booster, especially for long or frequently changing lists.
Makes sense. And what about styling directly in templates? Any best practices there?
Yeah. The general recommendation now is to prefer using direct class and style bindings in your template over the older in-class and in-style directives.
Why is that?
It's often just simpler, more readable, and potentially slightly more performant. You can bind directly to expressions like class.active is active or style.color, user color. It's usually clearer.
Okay. Now what about DOM content? That sounds a bit different.
Right, gun-done content. That's all about something called content projection. It essentially allows a parent component to slot or project its own HTML content into a designated spot within a child component's template.
So like making a reusable wrapper or card component and letting the parent decide what goes inside the header or body.
Exactly like that. The in-content tag acts as a placeholder in the child's template. It's not a real component or DOM element itself. Angular processes it during compilation. And you can even have multiple slots using the select attribute, like in-content select card title and in-content selects card body. This lets the parent project specific pieces of content into specific places in the child. Very flexible.
Cool. So beyond components and templates, we also have directives. They seem like another way to add behavior.
Yeah, directives are super powerful. Think of them as ways to encapsulate reusable behaviors that you can attach to elements. They can modify attributes, add CSS classes, listen to events, basically add custom functionality to existing HTML elements or even components without creating a whole new component structure.
Okay. And there's a specific type, host directives, that seems particularly interesting for component design, part of a composition API.
Oh yeah, host directives. This is a really neat feature, part of Angular's move towards better composition over inheritance. It lets you apply directives directly to a component's own host element from right inside its TypeScript class definition.
So instead of inheriting from a base class to get some behavior.
Exactly. Instead of being forced into potentially rigid inheritance chains, you can just declaratively say, hey, this component should also have the behavior of this tooltip directive and maybe this accessibility directive.
Like mixing in capabilities.
Precisely. It's like giving your components a menu of power-ups they can choose from. You pick and choose encapsulated behaviors from other directives. This leads to much more flexible, reusable, and maintainable components. You avoid that inheritance hell you sometimes see in big object-oriented systems.
That sounds like a significant improvement. Do the inputs and outputs of those host directives automatically become part of the component's API?
Good question. By default, no, they don't. The host directive's inputs and outputs remain private to that directive's behavior. But if you want to expose them as part of your component's public API, you can explicitly configure host directives to do that, so you have control.
Okay, so components don't just appear and disappear instantly, right? They have this life cycle from creation to destruction. And Angular gives us hooks to run code at specific points in that life cycle. What are the main ones we should know?
Yeah, understanding these lifecycle hooks is really crucial for managing things like data fetching, setup, and cleanup correctly.
Right.
First, you have the constructor. That's just standard JavaScript, runs when the class instance is created, very early.
Right.
Then, AngularInit. This one runs once, right after Angular initializes the component's inputs for the first time. It's the perfect place for initial data fetching or setup logic that depends on input values.
AngularInit for setup. Got it.
Next is ShedOnChanges. This one runs before enter-init the first time, and then every single time one of the component's inputs changes its value. It receives a simple changes object that tells you exactly which inputs changed, their previous value, their current value, and whether it's the first change. Ideal for reacting to input updates.
Okay, so that could run many times.
Well, definitely. Then you have Angular Destroy. This runs just before Angular destroys the component. Absolutely essential for cleanup. Think unsubscribing from observables, detaching event listeners, clearing timers, preventing memory leaks.
Cleanup is critical.
Totally. And there's also a modern alternative or addition here. You can inject destroy ref and register cleanup callbacks directly with it, which can sometimes be cleaner than implementing the anti-destroy interface.
Interesting. Destroy ref.
And finally, there's AngdoCheck. This one runs very frequently, basically before every change detection cycle. You should use this one with extreme caution. Only use it if you have some kind of change you need to detect that Angular can't catch on its own. It can have a significant performance impact if overused.
Okay, so AngdoCheck is the use sparingly hook.
Definitely. Stick to AngInit and AngOnChanges for most things, and AngOnDestroy or destroy ref for cleanup.
All right, so the app is running, components have life cycles, now it needs to talk to a server. Fetch data, send updates. HTTP client is Angular's built-in way to handle HTTP requests, right?
Exactly. HTTP client is the way to go. Methods like get, post, put, etc. return RxJS observables. And it's really important to understand that these are cold observables.
Cold. What does that mean?
It means the actual HTTP request doesn't happen just because you called get. Nothing happens until you explicitly subscribe to the observable that get returned.
Ah, so the request is lazy.
Precisely. And another key point, if you subscribe to the same observable multiple times, you will trigger multiple identical HTTP requests to the server. Something to be aware of.
Good to know. Can it handle different types of responses, not just JSON?
Yep. By default, it assumes JSON, but you can easily specify the response type option to fetch plain text or binary data as an array buffer or blob. Very flexible.
And what about interceptors? They sound useful for handling things like authentication or logging across many requests.
Oh, they're incredibly useful. Indispensable, really, in larger apps. Interceptors act like middleware for your outgoing HTTP requests and incoming responses. You can use them for all sorts of common patterns. Automatically adding authentication tokens, like GWTs, to headers.
Oh, that's a classic use case.
Right. Or maybe automatically retrying failed requests a couple of times with exponential backoff. Or logging request response times, or even setting up caching logic. They work by essentially intercepting the request response, cloning it because they're immutable, making modifications, and then passing the clone along the chain. It's a really clean way to implement these cross-cutting concerns without cluttering up your individual services or components.
Okay, next up, dependency injection, or DI. This feels like a core concept in Angular, how it provides services to components. How does Angular handle this, and what's the best way to do it now?
DI is absolutely fundamental to Angular. It's the mechanism for providing dependencies, like services, to classes that need them, like components or other services.
Right.
And the preferred way to inject dependencies nowadays is using the inject function directly within your class constructor, or sometimes even in property initializers.
The inject function, how's that different from just using the constructor parameters?
It offers much better readability, especially when you have multiple dependencies. And crucially, it provides significantly better type inference for the TypeScript compiler. This makes your code cleaner, safer, and often easier to refactor compared to the traditional constructor parameter decoration method. It's definitely the modern approach.
Better type inference is always good. Now, where you provide these services matters too, right? There's providers and view providers. What's the difference?
Right, the scope matters. If you list a service in a components providers array, that service instance becomes available to the component itself and to any child components within its template, and importantly, to any content that gets projected into it using content.
Okay, so providers is pretty broad.
Yes. Now, view providers is more restrictive. If you provide a service using view providers, it's only available to the component itself and its children within its view, its own template. It's not available to any projected content.
Ah, okay. So view providers hides the service from projected content. When would that be useful?
It's less common, but maybe if you have a complex component that uses an internal helper service, you don't want projected content to accidentally depend on or interfere with. Providers is much more common, though.
This idea of providing services at the component level seems powerful. Can you give a practical example of when that specific scoping becomes really important?
Absolutely. A key takeaway is that when you provide a service at the component level in its providers array, each instance of that component gets its own private instance of that service.
Okay, its own copy.
Exactly. This is crucial for scenarios where you need isolated state. Imagine a complex form component used multiple times on the same page, maybe for editing different items.
Right, like multiple modal dialogues editing different users.
Perfect example. Or maybe a tax preparation application, where an accountant's working on several tax returns side by side in different tabs or sections of the UI. Each tax return component instance needs its own isolated tax calculation service instance, so that calculations for one return don't accidentally affect another. Providing the service at the component level ensures this isolation.
That makes total sense. Isolation is key there.
Another powerful pattern is using component-level providers to substitute a more specialized version of a service deeper down the component tree. You could have a generic data service provided at the root, but a specific section of your app provides a specialized data service that overrides it just for that section. Very flexible.
Okay, navigating around a single-page application needs to feel seamless. Angular's router is the tool for that, mapping URLs to components. How does it make navigation easier?
Yeah, the router is essential. The router link directive is the main declarative way you set up navigation. You just add it to standard attacks.
So a router link users a symbol.
Exactly. It integrates directly with the router. Then the router outlet directive acts as a placeholder in your templates. It's where Angular actually renders the component associated with the current route.
The placeholder where the content shows up. Okay.
For handling dynamic data in URLs, you use route parameters. You define them in your route configuration with a colon, like users.ad. The router then extracts the value ID from the URL and makes it available to your component.
For fetching that specific user's data.
Right. And you also have query parameters for optional stuff, the key value pairs after a question mark, like users.sortName, useful for filtering or options. And a really nice recent addition is with component input binding. You enable this feature for your routes, and the router will automatically bind route parameters and query parameters directly to matching input properties on your routed component.
Oh, so no more manually subscribing to activated route params.
Exactly. It cuts down on a lot of boilerplate code. If you have an input into what string on your component and a .ad parameter in the route, with component input binding just wires it up automatically. Super convenient.
That does sound much simpler. What about how the URLs actually look in the browser's address bar? Does Angular force those hashtag symbols?
No, not usually anymore. Angular supports two main location strategies. The default, and the one most apps use, is path location strategy. This uses the HTML5 history API, push state, to create clean, normal-looking URLs, like your-app.com Cheezers133, just like a traditional multi-page website.
Okay, the clean URLs.
The other option is hash location strategy. This is more for older browsers or specific server configurations. It uses a hashtag symbol in the URL, like your-app.com #users123. But yeah, path location strategy is the standard for modern apps for better aesthetics, user experience, and SEO.
Got it. Okay, one more performance feature that seems really impactful, especially visually. NG-optimized image. This directive sounds like it bundles a lot of image loading best practices.
It really does. It takes a lot of the manual work and guesswork out of image optimization, which is huge for performance, especially LCP. So what does it do? Well, it automatically prioritizes images it detects as being the largest contentful paint element. It adds fetch priority high to them.
So the most important image loads first.
Right. And then, by default, it lazy loads all other images using the browser's native loading, lazy. This is great for initial page load speed. It also requires you to provide width and height attributes on your MG tag
Why does it require those?
to prevent layout shifts. By knowing the image dimensions up front, the browser can reserve the correct amount of space for the image even before it loads, stopping content from jumping around.
Ah, cumulative layout shift, CLS, makes sense.
Exactly. And you use it by replacing the standard SRC attribute with NGSRC.
Yeah.
That's how Angular knows to apply its magic. You can also explicitly mark your most important above the fold image with the priority attribute if the automatic detection isn't enough.
What if you genuinely don't know the image dimensions? Maybe they come from a CMS or user uploads.
Good point. For those cases, there's fill mode. You add the fill attribute to the image tag. This tells the directive to make the image essentially inherit the size of its parent container using CSS object properties usually. Very useful for responsive designs where dimensions are fluid.
Okay, fill mode. And I heard it does something with Circuit too, responsive images.
Yes, this is one of its most powerful features. If you provide width, height, and the standard sizes attribute, ng-optimized image will automatically generate an appropriate circset attribute for you.
Oh, really? Automatically?
Yep. It creates a set of image URLs pointing to resized versions, assuming you have an image CDN or backend that can serve them based on URL parameters, allowing the browser to pick the most optimal size. This dramatically simplifies implementing responsive images, which is crucial for saving bandwidth and speeding up loads on different devices.
That's impressive. It raises a question, though. How does the browser actually choose which image to download from that generated circ set?
Great question. The browser makes a sophisticated decision based on a few factors. The image's rendered size on the screen, which it determines using the sizes attribute and the current viewport width, the device's pixel density, is it a retina screen, and sometimes even network conditions. It tries to download the smallest possible image that still looks sharp at the required size.
Clever. And placeholders. Can it do those fuzzy low-res placeholders while loading?
It can. You can provide a placeholder attribute, often with a tiny, blurred, base64 encoded version of the image, a data URL. NG-optimized image will display this placeholder initially and then smoothly transition to the full resolution image once it loads. It really improves the perceived performance and makes the loading experience feel much slicker. #tag developer experience and security.
Okay, building great apps isn't just about the final product's features or speed. It's also hugely about the tools the developers use, right? The developer experience. And Angular CLI and DevTools seem like a real productivity powerhouse in that regard.
Oh, absolutely. The Angular CLI, the run command line tool, is your entry point for almost everything. You run new and boom, you have a working project structure in less than a minute usually.
Right, yeah.
Yeah. And gives you commands for building it, serving locally, links over, running tests, signers road and test, generating components, services, modules, everything you need for the development lifecycle, right up to deploying a production build.
Yeah.
And with the modern build tooling integrated now, using Vite and ESBuild under the hood, developers are reporting massive speed improvements. We're hearing about projects with hundreds of thousands of lines of code building in under a minute. That kind of speed allows for really rapid iteration and feedback loops.
Wow, under a minute for huge projects. That's impressive. And when things inevitably go wrong or you just need to understand what's happening inside the app, there are the dev tools.
Right. The Angular DevTools is a browser extension available for Chrome and Firefox. It gives you visual debugging capabilities. You can inspect the component tree, see the state of your components, profile, change, detection, performance. Really understand what Angular is doing.
Visual debugging sounds helpful.
It is. And beyond the DevTools, Angular itself has focused on improving the debugging experience. Stack traces and error messages are much cleaner now, pointing more directly to your code. And there are new dependency injection debugging APIs that let you inspect the injector hierarchy and figure out where services are coming from.
And for testing, anything to make that easier. Tests can be brittle.
Component harnesses. They're a fantastic addition for testing. They provide a clean, robust API for interacting with your Angular material components or even your own custom components during tests. Instead of selecting DOM elements with fragile CSS selectors, you interact with the component through its harness, which abstracts away the internal DOM structure.
So tests are less likely to break if you refactor the component's template.
Exactly. It makes your tests much more reliable, easier to write, and less coupled to the specific implementation details of the component's view. A huge win for maintainable test suites.
That's great. Now, shifting gears slightly, but still related to developer confidence, security. It's reassuring that Angular is built with security in mind, working with Google's security teams. What are some key protections baked in?
Yeah, security by default is a core philosophy. Angular has built-in mechanisms to protect users from common web vulnerabilities, especially cross-site scripting, or XSS. Its template engine automatically performs HTML sanitization. It treats all values bound in templates as untrusted by default and cleans them up, removing potentially malicious script tags or attributes.
So it tries to stop attackers injecting bad code through user input.
Precisely. It also supports trusted types, a browser feature that provides even stronger guarantees against DOM-based XSS. Now, if you have a very specific reason why you must insert HTML that you know is safe, maybe from a trusted source, Angular provides the DOM sanitizer service with methods like bypass security trust HTML.
Mm-hmm.
But you should use these bypass methods with extreme caution and only when absolutely necessary. The default is secure.
Okay, default safe. What about other common attacks, like cross-site request forgery, CSRF?
Angular has built-in protection for CSRF too. It uses a common double submit cookie pattern. Basically, the server sends a random token in a cookie, usually named XSRF token. Then, for any subsequent state-changing requests like post, putty, delete, Angular's HTTP client automatically reads that token from the cookie and sends it back in a custom HTTP header, usually XSRF token.
And the server checks if the cookie and header match.
Exactly. If they match, the server knows the request likely came from the legitimate front-end application, not from a malicious site trying to trick the user's browser into making unwanted requests. It's a standard and effective defense.
Makes sense. Any other security layers Angular encourages?
Yes, it strongly supports and works well with Content Security Policy, or CSP. CSP is a powerful defense-in-depth technique configured on your web server. It tells the browser exactly which sources are legitimate for loading resources like scripts, styles, images, etc.
So it can block malicious scripts even if they somehow get injected?
Right. Angular specifically supports using nonce attributes with CSP. A nonce is a unique random value generated for each request. You provide this nonce to Angular, using NDC as pnonce attribute, or the CSP and NCE injection token, and Angular will automatically add this nonce attribute to any inline scripts or styles it generates. The browser then only executes script styles that have the correct nonce value specified in the CSP header from the server. It provides fine-grained control and significantly hardens your app against XSS.
Okay, powerful stuff. And finally, just a quick but important note on reaching users globally, internationalization.
Right. Internationalization, or I-18N as it's often abbreviated, that's the process of designing and preparing your application so it can be adapted for different languages and regions. Localization, L10N, is then the actual process of translating the text, formatting dates, numbers, currencies, etc. for a specific locale.
And Angular supports this.
Yes, Angular has robust built-in support for I-18N. It uses the industry standard ICU message format, International Components for Unicode. This format is really powerful because it goes way beyond simple text replacement. It handles complex localization challenges like pluralization, different text for one item versus 5 items, gender selection, and various regional formatting rules correctly. It helps you build applications that can truly reach a global audience effectively and provide a native feel in different locales.
Wow, okay. We have definitely covered a lot today. From Angular's reactive core with signals, that whole performance story, to its solid component model, how it handles data, routing, even that surprisingly clever image optimization. Plus the developer tools and those really important built-in security features, it's pretty clear Angular isn't just, a framework. It feels more like a comprehensive ecosystem.
Yeah.
Designed for building really powerful, scalable, and maintainable web apps, often with that confidence by default feeling we talked about.
That's a good way to put it.
So thinking about all this, how Angular tackles complexity with security by default, performance by default, this structured approach that nudges you towards best practices. It kind of raises a final, maybe provocative thought for you, our listener. In today's world, with web vulnerabilities seemingly everywhere and performance demands always increasing, how much of your choice of a framework, or any tool really, is purely about the flashy features it offers? And how much is, or maybe should be, about the built-in guardrails, the safety nets, the best practices it automatically enforces for you? What kind of confidence does your current tech stack give you right out of the box? Something to think about.